from University of Kentucky. Welcome.
Thank you. Good afternoon, everyone. Thank you all for hanging in there. Apologies for the messed format, but we'll strive through it. My name is Hala Nassereddine. I'm an associate professor of construction engineering and project management at the University of Kentucky. And I'm here presenting on the behalf of my PhD student, Amin Khoshkenar. If you have anyone in the US, an Iranian student, you know that they can go into the US, but they can't leave. So unfortunately, he wasn't able to make it here, but this work was led by him. And we're basically exploring digital twin platforms across different industries using a multi-aspect social network analysis. So not to kind of repeat what was mentioned in the previous presentation, but in the recent years, digital transformation, digital twins, they have been making the headlines in almost every industries, including this conference as well. And if we want to put a definition to digital twins, there are really different definitions. I'm not going to bore you with the one that we have on the slides. But if we have to think simply about digital twins, it's really about the physical asset system, you can call it entities, and the virtual asset system, model entities, and the data that connects the two together. And there are multiple benefits. You can't see this one right here, but these are the benefits of digital twins. And we can really talk about some of the realized digital twin benefits in the industries that are already using digital twins. And we can also talk about some of the expected benefits. And those include enhanced quality, efficiency, reducing costs across different aspects of the organization, mitigating loss, risk mitigation, improved safety, typo, and then energy conversion, and that's mostly when we talk about preventive maintenance. So when we talk about digital twin, we talk about the physical, the virtual, and the data. Specifically, when we talk about the virtual and the data, we need to have platform to host the models and the data that connect the virtual and the physical. And that's when we start talking about digital twin platforms. So digital twin platforms, they provide the core infrastructure to really create and manage and utilize the data that is being enabled between the physical and the virtual assets. Digital twins could be for organizations, could be for projects. A project in construction is technically a temporary organization. It could be for facilities. So there are really different uses for digital twins. And when we talk about creating a digital twin platform, we really need to talk about the ecosystem of creating digital twin platforms. And those include the providers. They also include the application developers, technology providers. We talk about Internet of Things, cyber physical systems, system integrators, APIs, consultants, and then the users themselves. And if we are to just consider construction as its own industry, we have multiple stakeholders. They span different industries, not just one. We can talk about energy, manufacturing, materials, and everything else. So in order for those digital twin platforms to be capable, they really need to be featured multiple capabilities, and those span different capabilities from data ingestion to scalability, which is by far a really difficult capability to achieve. There's a lot associated with it. Interoperability, which we've seen from the previous presentation, that's a big one. Security, simulation, and then analytics, which is by far has been the core of digital twins. So the ultimate objective for us, for my research group, is we're trying to more explore digital twins for construction in specific. And for us to do that, we wanted to kind of do reverse engineering. We wanted to go back, see what is currently being implemented, analyze those solutions, to learn and try to create a solution for the construction industry. So to do that, we ended up reviewing platform sources, looked at press announcements, and looked at providers and users' websites for digital twin platforms. And we ended up collecting 18 different unique digital twin platforms that span 6 different countries and 58 solutions. From the user side, these 18 unique platforms, they span over 40 industries, and then they are being used in 19 different locations. When we reviewed all of the 18 unique platforms, we ended up evaluating 10 different variables. I'm not going to go through each one of them, but we basically extracted information related to the provider, the year it was provided or launched, the purpose of the platform, the industry, the users, and then we looked also into the solutions that are being offered by the platform. All of this information was stored in Excel spreadsheet, and eventually we used Pagic software to analyze. The student used, let me correct myself. The student used Pagic software to analyze the spreadsheet and create a network. And the purpose of creating this network was really to try and understand different aspects of digital twin platforms. And I'll go through some of these aspects on the next slide. So top platforms, Azure Cloud was found to be the top platform used with 18th for degree of centrality. IBM Cloud came in second, MindSphere and Vuforia. When we talk about the security mechanisms, which is a main capability for digital twin platforms, we talk about three main ones: authorization, authentication, and encryption. Then we talk about the interaction methods, the twin interaction methods. That is the interaction between the physical and the virtual. We talk about service API, bidirectional synchronization, and interface simulation. For the leading industries, manufacturing by far is the leading industry in digital twin platforms. They have more repetitive work than other industries. We talk about automotive, aerospace, and energy. Digital twin, I have to say, started in the aerospace industry. And then we analyzed the 58 solutions that we extracted, and we ended up fitting them into those 5 categories: virtual modeling, simulation, predictive analysis, connectivity and data integration, immersive interaction, and lifecycle management. And those are quite similar to what the presenter in the previous session showed. Another kind of analysis that we did is community detection analysis. We basically tried to put all of the data together just to see if there are any patterns or trends associated with digital twin platforms. And the purpose of doing this analysis was basically to try and look into, are we able to understand if there are particular industries that require specific capabilities or not? So I'm not going to go into the analysis. This is still, we're looking more into this data, but you can see, for example, here that MindSphere, for example, is heavily used in the US, Germany, and it's being used in agriculture, for example. So there are some patterns that could be identified through the analysis that we did. So just to conclude, we've seen that there are multiple solutions being offered for digital twin platforms. They all really depend on the location, depend on the industry, depend on the application. There are different capabilities that technology had quite advanced in making them a reality, but there's a long way to go with digital twin platforms, especially when we talk about scalability, interoperability, in construction in specific. The biggest thing in construction is ownership. When we talk about the digital twin, is it the digital twin of the construction project? Is it the digital twin of the facility at the end? Who is going to be the ultimate end user? And that obviously gets us into a discussion of who's going to pay for all the data that needs to be collected and stored on the cloud, maybe. So for future work, we're really talking to some of the providers to kind of try and get some thoughts about the implementation. We're talking to some of the users, and then we're trying to conduct some longitudinal analysis just to see the sustainability of digital twins. And mostly all of that is going to lead us to developing a framework that would help organizations in investing in digital twins and just knowing exactly what goes into investing in digital twins. With that, thank you so much.